Hi viewers, let us see the KEIL and PROTEUS programming. So we know very well 8051 is a 8-bit microcontroller which is used to write different programming in assembly language and we can perform lot of operations like arithmetic operation, logic operation, control operation, etc. At the same time, lot of interfacing can be done with the help of this 8051. That is DC motor interfacing, stepper motor interfacing, 7-segment display interfacing, etc. These are the variety of programming using assembly language programming. Otherwise, simply we can say it is low-level language programming. So, if you do the same operation with the help of some softwares, so that is called as the high-level language programming. So, instead of assembly language or low-level languaging, we move to embedded C programming with the help of KEIL software and whatever we want to interface, everything can be interface and we can able to get a proper output in hardware also. So in this program we are going to use KEIL software, at the same time Proteus simulation tool. Both are dumped together and we can write embedded C program. What operation we want to perform, everything can be written in the programming area, that is source code area, and we can save it as a .c file and we can execute it. After compilation, we can dump this program to Proteus tool. Finally, we will show our output or view our output with the help of Proteus. So let us move to the example. So the first program, I am going to toggle the various 8 bits in port 1. So in 8051, there are four ports are available: port 0, port 1, port 2, and port 3. So totally 4 ports are available. Out of this 4 ports, here I prefer only port 1. So totally these all kind of ports consist of 8 bits. So each and every 8 bit of ports, totally 32 bit of 4 ports are available in 8085. So out of these 4 ports, I prefer port 1 here for performing the toggling operation. ஸோ சிம்பிளி we can say, நம்ம இப்போ நம்மளோட பஸ்ஸில் எல்லாம் போகும்போது பார்த்தீங்க அப்படின்னா சாமி ஃபோட்டோஸ், காட் ஃபோட்டோஸ்லாம் வச்சுருப்பாங்க. ஸோ அதில் வந்து எல்இடி ஆப்ரேஷன் இருக்கும். ஸோ ஆல்டர்னேட்டாக வந்து ஒவ்வொரு எல்இடியும் வந்து மாற்றி மாற்றி எரியிற மாதிரி இருக்கும். த சேம் ஆப்ரேஷன் வி ஆர் கோயிங் டு டூ ஹியர். ஒரு ஒரு எல்இடியும் மாறி மாறி இது ஆன்ல இருக்கீல அது ஆஃப் ஆகும், அடுத்தது ஆன்ல இருக்கீல அடுத்தது ஆஃப் ஆகும். கண்டினியூஸ்லி that operation is going on till you are going to switch off the light. அதே ஆப்ரேஷன் தான் நம்ம இதுல பார்க்க போறோம். So before going to write a program, we have to take some procedure in KEIL software and also Proteus software. So let us see this. So first you have to open this KEIL tool. After this you go to project, click new project. So here it will ask in which location or directory you want to save your project, like this. So I save it in E drive. If you want to save in different name, you can include a different folder. For example, if you want to do the various experiments, like 50 experiments, 20 experiments, likewise if you want to do like this, so you can give a name. I just take create a folder ex1. So in this ex1 folder, I just give program name, that is simply I give project name is a P1, project P1, and I save it here. So now the P1 is saved. So this P1 dot muv project microvision is shown in this header lines. So that is your P1 is the project name for this particular project. So here you have to move to Atmal. So in this Atmal, see micro chip. So here you have to select 89C51. because Atmal 89651 is the one kind of 8051 microcontroller. So the particular chip can be taken for operation. So that is taken here. Now you have to give yes. So after pressing yes, here the project window will be opened. In this, the target and source group is created. Within the source group, the startup A51. It should be shown in this project area under source group 1. So now you can go to file and give new. So now the text area, that is the programming area, will be open. In this window, what program you want to write, the entire source code can be written here. So just I write a program, hash include register 51.h. So normally in a C program, so actually this program is an embedded C program. In C programming, we are including lot of library files like hash include stdio.h, hash include conio.h, math.h, string.h, etc. So include stdio.h means standard input output operation should be included. So what type of operation we want to use, for that purpose we have to include that library file. And if you want to perform string concatenation or string shifting, etc., so for that you have to add a string.h library file. Similarly, math operation is needed to perform for various programming means math.h library file should be included in a program. So these are the various library files should be included whenever you write a C program. So this is the embedded C program. So in 8051, we are going to execute all the program. So for that, what are the different registers and variety of operations needed to execute? Everything can be included with the help of this register 51.h. So after that, I am going to start a program. So simply I just start void main void. So next I open a open curly brace, and here I have to perform one operation P1. That is, I take port 1 is the my port, and I give the value which is equal to 0x AA semicolon. So that means here the port 1 is taken for 8-bit operation. At the same time, AA is a hexa value. So here we are going to perform toggling the 8 bits continuously with some delay is our program using port 1 with the help of KEIL and PROTEUS simulation tool. So for that, P1 is equal to 0xAA value is assigned in this P1. So here 0x is representation for hexadecimal values. This AA is the hexadecimal value which is assigning in port 1, which is dumped to the 8051 microcontroller. So because all microprocessor and microcontroller performing different operation with the help of binary data only, but as a programmer we can't able to give directly binary value to the microprocessor or microcontroller. So at that time we have to give only hexa value. So this hexa value is taken here. So AA means 10101010. So the lower nibble 1010 and higher nibble 1010 is taken as a AA hexadecimal value. It is load into the port 1. So at the same time, again you can type P1 is equal to 0x55. So now the alternate toggling is taken place here. 55 value is 0101. Again, this lower nibble 5 value is 0101. So totally 8-bit values are assigned in port 1. First value is 1010. 1010, again 01010101. So totally 8-bit of values are assigned in port 1 separately for alternate toggling continuously. So I just close this program. So that's all about our program. Now we have to execute it. Before execution of this program, we have to save this program. So I already create one folder in E drive. So example 1. So in this I can give p11.c. You have to remember one thing, always the project file and the source coding file should be different. The same name should not be there. So we have to ensure that. So now I save the file name, embedded C programming file name p11.c. Now we have to add this program into our project p1. So for this, I have to go for target, right click it, options for target, and here we have to select a crystal oscillator frequency value 12 megahertz, and we have to create this entire project into hex file. This hex file only going to dump into the Proteus simulation tool. So for this, you have to enable this create hex file in this checkbox and click OK. After this, move to source group 1, right click it, and after this, add existing files to group. So in this, the object is there. So here example 1 is there. So in this example 1, p11.c, this is our source file name. So that is selected here, and select add and close it. Now the source file p11.c file is added into our project 1. So now the process is over, and save it again, and we can compile it. So for compilation process, we have to press F7. Otherwise, simply we can select this menu bar. The compilation is going on, and build output is completed. The hex file for this project 1 is created successfully. So now the KEIL programming work is over. Let us move to Proteus simulation tool. Here we go for new project file, new. So if you start very first time, you simply click the Proteus simulation tool, and here ISIS file is there. Just click it. You just click it. So the schematic area will be open, and in this area, the place pick device is available here. We just click it, and if there is no possibility to take directly, we select a library and pick the device here. Atmal 89C51. We have to enter, and this device is available here in this library. We select it and paste it in our schematic area. After that, here we need 8 LED for toggling purpose. So I simply type in pick device area LED. So in this LED, we can use animated LED. I just select active animated LED green and red. So first I take green LED. 4 green LED can be taken, and I just place it here. Again go for a pick device. Here again type LED, and you have a LED animated. So I just take red LED. Again I place it in between of this green LEDs. So now the LEDs are picked from pick device area and place it in a schematic capture area. Now the picking devices work is over. We just right click it and rotate clockwise. Arrange all the LEDs like this. Rotate clockwise, operation is taken place. Now let us connect the port 1 with all the LEDs anode terminal. So the totally in port 1, 8 bits are there. So port 1.0, port 1.1, port 1.2, etc. till port 1.7. So the all 8 bits can be connected with anode terminal of different LEDs. That is 8 LEDs. Now connection part is over. We have to carefully connect this wire. If any dots or some other unwanted component is placed in between this schematic area, the program will not be run. So finally, after completing this process, we have to take ground. So go to this place, terminals modes is there. In this, we can select ground and place it here. After placing this ground, we just connect all those things. That is the cathode terminal of all LEDs are connected here. So whenever you draw the diagrams, it should be neat. So it should be look good. So at the time only the interest will create to do more experiments and enrich your knowledge in this Proteus tool and also KEIL programming. So now the different parts selected from this programming tool and connection part is over. Now save it here in this. So go to experiment 1 and give experiment 1. So this is our file name for this Proteus. So now the work is over. Now double click it and here you have to select this program file. So in this program file, you go for drive EE. After that, in this program, in experiment 1, already we have created the hex file. p1.hex. So now you run the program continuously. The LED is on and off. So that means toggling the LEDs continuously with the time duration. It is taken place here. Now again, if you want to change the program, so here I can give never ending loop, that is for semicolon semicolon. So till the execution should be stopped. So for that we can give the never ending loop. After that I want to give some time delay. So for that I just give I equal to 0, I less than 10,000, I plus plus. Again the same operation I want to do, that is continuous delay should be given for the second port operation. So here we have to initialize this I, because here we are using the new variable I. So that variable should be included. So in global declaration, I just give int I. Now we can save this program. Again, you can compile this program, that is built. Now the hex file is created. After this, you move to Proteus tool. Again, you dump this program. You browse it, p1.h, and click OK. Now, press run button. So, based on the different time delay duration, the LED of 8 bits for different port bits P1.0, P1.12, P1.7 are alternately on and off continuously. So this is the program for execution of the port 1 8 bits are continuously toggling with the help of 8051 using KEIL software and Proteus software. I hope everyone understand this concept. Uh, Thank you for viewing this video. Thank you all. Kindly subscribe this video. Thank you.